Section 1.1, Language of Algebra. Multiplication signs come in a variety of ways. You can have the typical X between the numbers to indicate multiplication. You can have a dot between the two numbers to indicate multiplication. You can have the numbers in close proximity where one of the numbers may be in parentheses or both may be in parentheses, indicating multiplication. Division can have the typical division sign. You can have a fractional content, or it can have the standard form for the radical. Expressions. Expressions have no equal sign. Equations have equal signs, but expressions do not. For example, 4a plus 7, a is the variable. It is the unknown. 4 is the coefficient of the variable. It tells you how many of the variable you have. And 7 is the constant. 7 will always stay 7. Section 1.2, Fractions. A prime number is a number greater than 1 that has only itself and 1 as factors. For example, 7. The only factors or the only divisors of 7 are 1 and 7. Composite numbers is a number greater than 1 that has more than 2 factors. For example, 30 can be a combination of several numbers when multiplied. So the prime factors are 2 times 3 times 5, where the 2, the 3, and the 5 are all prime numbers. Other factors of 30 are 6 and 15. Prime factors. Let's start with the number 210. You can start with any two numbers multiplied that give you 210. For example, we know it ends in a 0, so we could start with 10 times 21. Well, 10 is not prime, so we break that into 2 times 5, and we break the 21 into 3 times 7. Now suppose you had started with another number. Like 210 could be 7 times 30. So the 7 is prime, so you bring that straight down, but the 30 is not. So 30 becomes 5 times 6. 7 is prime, you bring that down. 5 is prime, you bring that down. But the 6 becomes 2 times 3. Wherever you start, you're going to get the same results as the prime factorization is 2 times 3 times 5 times 7, or 210. So any number, such as a divided by itself, is always 1. And a divided by 1 is always a. In other words, any number divided by 1 is that number. Now, when we're multiplying fractions, we can multiply the numerators together and the denominators together. So a divided by b times c divided by d. Numerators, a times c is ac, b times d is bd. So if you have 7/8 times 3/5, 7 times 3 is 21, 8 times 5 is 40. Division is a little bit different. A over b divided by c over d. The first fraction remains the same, but the fraction after the division sign becomes inverted. So the division goes to multiplication, and then we just multiply numerators and denominators. So in this case, a times d, ad, b times c, bc. So in an example of two fractions, if we have 1/3 divided by 4/5, the 1/3 stays the same. Division goes to multiplication, and the second fraction becomes inverted, 5/4. Now we're back to multiplication, so we can simply multiply the numerators. 1 times 5 is 5. Denominators, 3 times 4 is 12. Equivalent fractions means that they're equal. But notice they have different denominators. So to get from 3/5 to 6/10, you would have to multiply the numerator and denominator, excuse me, by 2. Or you could say 5 goes into 10 2 times, and there's 3 of them, so 2 times 3 is 6. Likewise, if you start with 6/10, that can be reduced because both the 6 and the 10 are even numbers, so we know both of those are divisible by 2. So 6 divided by 2 is 3. 10 divided by 2 is 5. Now, if you're dealing with big numbers and you want to see if it's reducible, the best thing to do is to put the numerator and denominator into primes. So 90 becomes 2 times 3 times 3 times 5, and 105 becomes 3 times 5 times 7. So these 3's cancel each other, and the 5's cancel each other. So now we're left with a 2 times 3 for the numerator, or 6, and the only thing left on the bottom is, or for the denominator, is 7. So we have 1 times 1 is 1 times 7 is 7. And we will continue on 1.2 in a moment.